Okay, this is section 2.7, absolute value functions and graphs. We're going to continue along the lines of graphing equations, and we're going to talk about different types, and this is one of our different types. Our objective here for this section is to graph absolute value equations. Okay, so it's going to be important to know what absolute value number one looks like. So the simplest example of an absolute value function is f of x equals the absolute value of x. Now, you could also write this as y equals the absolute value of x. Now, they put it in what we call function notation, and we haven't quite talked about that yet, but we're going to talk about that later, but you don't need to necessarily worry about the function notation part of things. Okay, and this is what we call the parent function. Parent function or the parent equation. Okay, it's the simplest form of that equation. Okay, the simplest form of that equation. The graph of the absolute value of a linear function in two variables is V-shaped and symmetric about a vertical line of the axis called the axis of symmetry. So it's in the shape of a V. Okay, it's in the shape of a V, and it's symmetric. Now, symmetric is an important word to know. Symmetric means that it's same. If I were to cut it right down the middle, it'd be the same on the right side as it is on the left. Okay, such a graph has either a single maximum or a single minimum called the vertex. The vertex is the sharp point that it will come to. Okay, so we're going to talk about some more of these things: the axis of symmetry, the vertex, how to find them, and what they mean, and how important that is. Okay, so the absolute value parent function. As we look at this here, the absolute value parent function, f of x equals the absolute value of x. Okay, what they've done here is they've given you a table, and they've decided to put in the numbers for x from -3 to +3. And if they put those numbers in, this is what they get out. Okay, and they graphed it here as well. Okay, they graphed it. And you'll notice in your graph, they show you the vertex, which again is the sharp point. And what they also show you is the axis of symmetry. Okay, we're going to get into how to find that. Now, the axis of symmetry, I can go ahead and say this right now, is x, the line x equals h. It is a vertical line that cuts the graph in half. Okay, it's the vertical line that cuts the graph in half. So as you look at this picture here, as I look, the axis of symmetry happens to be the y-axis. If I were to cut this and take it and separate it apart into two parts, it'd be the exact same on the right as it is on the left. It'd be a mirror image of each other. Okay, so that's the most basic absolute value function, the parent function. Now, what they're going to do now is they're going to add things to that parent function equation. This parent function equation, they're going to add things to it, and what it's going to do is it's going to shift this basic graph right here, right, left, up, down, make it taller, make it shorter, stuff like that. Okay, so as we look now at the key concept here, the family of absolute value functions. Okay, so as we look here, we got the first one is what we call a vertical translation, or when it moves up and down. Okay, anytime you add a number, again, here's the parent function. If you add or subtract a number outside of the absolute value, it's going to shift it up or down. Obviously, if it's positive, it's up. It's negative, it's down. Okay, this is what we call a K value. Okay, so the translation is up, or the movement, the shift. Translation and shift mean the same thing. So translation is the same thing as a shift if you move something. Okay, so as we look at this, again, if we add something or subtract something on the outside of the absolute value, it's going to move it up or down. If we add something or we subtract something on the inside of the absolute value, it's going to shift it what we call horizontally. Or this is going to be right and left. Okay? And it's always the opposite. So on horizontal translation, it's always the opposite of the sign. So if it's positive, if this number is positive inside the absolute value, you're going to shift it left. If it's negative, you shift it right. It's always the opposite of whatever that value is. Okay? All right, just stretch it and compress it. So when I stretch it, it would be like me taking a rubber band between my two fingers and pulling it up and down, and it's going to stretch it out. Okay, it's going to make it way narrow. It's going to narrow it up. If I compress it, if I were to take the two rubber bands between my fingers and pull them apart and push them all the way together, it's going to make it fatter, or it's going to compress it together. Okay, and the key here with this is if A is greater than 1, it's going to stretch it out. If A is between 0 and 1, it's going to compress it or squeeze it together. Okay. All right, the last one you're going to see is a reflection. Okay, reflection. The reflection here, okay, it's going to reflect across the x-axis, it's going to reflect across the y-axis. In other words, on the x-axis, if we flip it across we reflect it across the x-axis, this is going to flip it up or down. Most of the time, you're going to see this guy. You won't see this one very much in reflecting in the y-axis. Okay, so it's going to flip it from facing up to facing down. And again, we're going to go through some examples here. You're going to see some of these. Okay, so this chart right here is a very important chart to pay attention to because it talks a lot about each different parts of the movement. Okay. All right, how we're going to graph an absolute value equation. Okay, the very first step says we're going to identify the vertex of the graph from the equation. You will plot this point on the graph first. Now, the vertex, as we look at this guy, the vertex is always the opposite of h and k. Okay, the opposite of h and k. Now, they'll say that it's h and k, but that's essentially meaning the opposite, because if you look at the actual equation of an absolute value, the general form of an absolute value equation is y equals a times the absolute value of x minus h plus k, and the vertex is always going to be the ordered pair h and k. Well, you'll notice that as you look at this right here, the h's are the opposites of each other. It was negative here in the equation, and it's positive to find the vertex. Okay? So we're going to identify the vertex. We're going to plot that on the graph first. We're going to identify the axis of symmetry. The axis of symmetry is x equals h. You'll use the value of a just like you would the slope of a line from the vertex. You will plot your next point using the letter a. And again, like I said, you'll go through and I'll show you these as we go through on this example. Number 4, then you will use the axis of symmetry to reflect across the line, the point to find your other point, then draw your two lines. And again, your shape's going to be your graph is going to be in the shape of a V. Okay, so let's take a look at some of these examples, and it'll help explain a little bit better here. Okay, again, I'm going to write down the general form of an absolute value equation. Y equals a times the absolute value of x minus h plus k. Okay, now as you look at this equation, y equals the absolute value of x minus 4. Is there an h there? You'll notice that there isn't. There's no number in there with the x. So the vertex here for this, there's no number there, so the h is 0. The k is right there, which is negative 4. That's going to be the vertex. Okay. Now, if you look before the absolute value, that's where a is. Is there a number there? No. So if there's not a number there, we always understood it as a 1. So the slope is going to be 1, or 1 over 1. Okay. Now, the axis of symmetry. Is the line x equals h, when in this case h is 0. Okay, so the very first thing I want to do here on this is I want to plot the vertex. The vertex is at 0, negative 4, so I start at 0 and I'm going to go down 4 units and put a dot. So 0, -4 is right here. Put a dot. Okay. From there, I'm going to use my slope, and I'm going to go up 1 and right 1. Put another dot. Okay. And I can go up 1 and I can go right 1 more. Put another dot in there as well. I mean, usually we'll go 5 points usually on the graph. Okay. Okay. So the axis of symmetry is the y-axis because it's the line x equals 0, which it happens to be this guy right here. Okay. So what we can say is if I reflect it, it's going to be the same distance from this point to that line. So this point right here is 1 unit away from the line, so my other side is going to be exactly 1 unit away. This point right here is 2 units away, so it's got to be on the other side also 2 units away as well. And now I draw my 2 lines like so, and now we have a V-shaped graph of an absolute value. Okay. All right, let's take a look at this second example. Again, this one's a little bit different. So we got to find the vertex. Vertex is the opposite of this number and k. So the opposite of -2 is +2, and k is 1. So that's our vertex. The slope of the lines that we're going to have is not there, so it's going to be 1 again. The axis of symmetry is the line x equals h, and h is 2. Okay, so again, going to do the same concept. We're going to plot that vertex first. The vertex is right 2 and up 1, which goes right there. From there, I'm going to go up 1, and I'm going to go right 1, and up 1 and right 1 more. Okay, the axis of symmetry is the line x equals 2, which you're seeing me put a dashed line down here. Okay, that's the axis of symmetry. How far is each point from that line? That's how you're going to determine. This first point right here is 1 unit away, so we're going to put it 1 unit on the other side, right to the left. The second point is 2 units from it, so I've got to go 2 units to the left. And now I can draw my absolute value graph. Once you get used to using these become pretty similar in how you're graphing them. Okay, so again, you'll notice as we look here, the key concept, general form of an absolute value function, this is our general form of an absolute value equation. Okay, and we'll look here, this number right here tells us how much it goes up or down. This number here tells us how much it goes right or left. Remember, if it's negative, it goes right. If it's positive, it goes left. And this number here tells us whether it's going to stretch, which is going to make it very narrow, or it's going to compress, which is going to really widen it out. Okay. And also this letter over here, A, we treat just like the slope of a line. Okay. So again, the stretch or compression factor is the absolute value of A. The vertex is located at the opposite of H and K. You'll notice H here is positive, as you see in the ordered pair. H up here is negative in the equation. So it's always the opposite of H and K, and the axis of symmetry is the line x equals whatever the value of H is. H value of the vertex. Okay. So let's go through and finish up these last 2 problems here as we look here. We want to graph these 2 guys. Okay, so again, very first thing we want to do as we look at this guy is identify the vertex. So the vertex, the opposite of H, which is -4, and K, which is -3. Okay, the A value or the slope this time is no longer 1, it's 2, or 2 over 1. Okay, and as we also look at this guy, we want to identify whether it's a stretch or compression. So in this case, let's take a look at graphing this guy, and let's notice how it's different from the parent function. Okay, And I'm going to put the parent function down here so that you can see what the parent function is going to look like. This is the parent function of the absolute value. So you can kind of get an idea of how the shift works with this. Okay, so I'll make that guy in black, and I'll change this and make the new one in blue. So our vertex now is left 3 and down, or sorry, left 4 and down 3. So right there is our new vertex. Okay, and our slope is 2 over 1. So this tells me I'm going to go up 2, I'm going to go right 1 from that vertex. I go up 2, I go right 1, put a dot. Up 2 and right 1 from that spot, put a dot. Okay, the axis of symmetry is the line x equals h, which in this case is -4. That's the axis of symmetry. Okay, so I'll put a dotted line there. Right here is our axis of symmetry. Okay, we've got this side right here has a line like so. And now again, this point right here is 1 unit from the axis of symmetry. So it's got to be 1 unit to the left. And this here is 2 units, so it's going to be 2 units to the left. And now we have our graph. Like so. Okay, and you'll notice compared to the original picture of the parent absolute value function, it has taken and narrowed it, so it's squeezed it in together, stretched it out, and it also moved it to a different location. So the shift here, and yes, you will have to identify shifts every now and then. The shift is that it moved left 4, down 3, and it stretched by 2. Okay? Alright, now let's take a look at this next one, and then this last one here is a little bit different as we look at this guy. So, again, identify the vertex, and in this case you'll notice this equation is a little bit differently. Anytime we have a negative in front of that first value, that x value, we're going to set that guy equal to 0 and solve, because it's going to change our x value of our vertex. So if I add 3, negative x equals 3, and if I divide by -1, x is going to be -3. So the vertex value now is -3 and +9. Okay, that's going to be my vertex. The slope, there's no number for a, so it's a 1. We're going to go up 1, right 1. Okay, the axis of symmetry is at the point, the line x equals -3. Okay, so I'm going to plot this point. I'm going to go left 3, up 9. Right here, put a dot. From there, I'm going to go up 1, right 1, and up 1, right 1. Draw my line on the right side. Again, reflect it across. The line x equals -3. Draw it on the other line. Now the shift on this guy, we went left 3, we went up 9, and we didn't stretch or compress anything, so that's the only shift we had. Okay? So now you should be able to graph any absolute value equation that we have. I've given you quite a few examples here to look at, give you an idea of how to graph absolute values. This concludes section 2.7. Or I'm sorry, this doesn't conclude it. We've got one more page yet. Alright, we've got 2 last problems here. I'm not concluding this section. It says, identifying transformations without graphing this thing. What are the vertex and the axis of symmetry of the graph? So, again, we should be able to identify the vertex pretty easily. The vertex here is the ordered pair 2, 4. The axis of symmetry is x equals h, and h is 2, so that's x equals 2. How is the parent function transformed?
Students.
Okay, how is the parent function transformed? And this is the same thing as saying shift. How is it shifted? So the shift on this, okay, the shift on this thing is we're going to go right 2, we're going to go up 4, and then don't forget this a value. This says we're going to stretch, because it's greater than 1, by, we call it 3 units. Okay, so that's the actual shift. All right, and then the last problem that we're going to look at is you're going to go backwards now. Okay, so you got to, what is the equation of the absolute value function? So now I'm going to give you the graph, and you got to come up with the equation. A couple things on this. Number 1, identify the vertex. That gives you h and k. Remember, y equals a times the absolute value of x minus h plus k. That's our general form. 2, identify the slope of the line. Okay, identify the slope of the line. So you're going to take this line, go from one point to another, find the slope. That becomes A. And then you're going to substitute those 3 things in. Okay, so as you look at this graph, this point right here is the vertex, and that is the point, the vertex is at the point -1 and up 4. That's our vertex. This is h, and that's k. Okay, now you'll notice again, here's a point on the line, and here's a point. You want to try and find points where there's intersections. You do it here as well too. Okay, so to get from this point right here to this point, I have to go down 1, and I have to go right 3. Okay, so that means that the slope is down 1 and right 3, or the slope is the same thing as letter A. So now my equation is going to be y equals, A value is the slope, -1/3, times the absolute value of x, and it's -1, h is -1, so it's going to be minus -1, and then plus 4, and then we got to clean this thing up right here, so it's going to be y equals -1/3 times the absolute value of x plus 1 plus 4. Okay, so now you should be able to find any equation from a picture of a graph. Okay, now this does conclude section 2.7, absolute value functions and graphs.